From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Thank you very much for having us today. So I'm Hajid. I'm here with Jeremy, actually, to show you how we did manage to deploy simplified and portable cloud-native architectures. So without further ado, when we speak about cloud-native architectures, we start with the big elephant in the room, which is microservices. So today, actually, we are going to go through the history of microservices and why we need microservices in order to deploy cloud-native architectures. Actually, this is a big issue. This is one of the biggest reasons that we did start all the cloud-native stuff, Kubernetes, high availability, and scalability. So, classic microservices, actually, I would like to start with a basic definition. What is microservice? I think here in the room, we've got some developers. Who is a developer here in the room? Cool. I think we've got some DevOps engineers also. Who is a DevOps engineer? Cool, I can see both here. So this is the goal of this talk, actually, to see both of the sides, how we can see microservices from developer perspective and from DevOps engineer. So basically, by definition, microservice is a single entity with a business focus, well-scoped, limited scoped, which has a specific role in a whole business workflow, but from the operations side, it is independent. So you can scale it, you can apply some security principles, you can do some high availability best practice on it alone. That's the utility of microservices, actually. But the thing that we did remark in classic microservice architecture that it's tightly coupled with the technologies. Those microservices alone are useless. So we need to guarantee the communication between those microservices in order to deliver a fully working workflow, business workflow. That's why we need the layer of the tooling or the layer of technologies like Kafka, for example, for messaging, Redis for caching, and for specific uses like MongoDB for database or something. So we need a set of tools. But the classic microservices architecture, as you can see in the schema, this graph actually is an e-commerce application that we did develop for the purpose of this demo, actually, that it's tightly coupled with the technology layer. So we are going to challenge this classic microservice architecture where we are starting basic. So this is a basic microservice architecture, and we are going through this architecture in order to enhance it and in order to have a very simplified and really portable cloud-native architecture, microservice architecture. So in order to deep dive in the issues and the challenges of microservices, I'm going to hand over the flow to Jeremy to explain for us the challenges from monolithic to microservices and what are the hard parts, actually.
Hello, everyone. I'm Jeremy. I'm so glad to be here with you. I had so many troubles coming to Hamburg with the flight that's been cancelled and so on, but I finally made it to be there and serve you. So let's get back to our main topic. You can see this post from Vlad, who is a famous Java champion on LinkedIn, and he's saying how his software is built this day. So we have the basic thing, our microservice that needs to fill up a business purpose, a bike, so to travel, and we have added multiple components on it. So that's where we are today on microservices. We moved from monoliths to microservices, but it comes at the cost of adding more and more components. The real cost is not really adding the few lines of codes that you will need to connect to Kafka or to connect to HashiCorp Vault, but it comes with finding the right libraries that you will need to include in your project. Then ensure that the library you will use to connect to Redis is compatible with the one you will use to connect to Kafka. You will then need to do the security updates, so to patch the vulnerabilities of these libraries. And the complexity will not increase linearly, but exponentially with the numbers of components your microservice will connect to. Each component will need to be compatible with all the others. So every time you add a new component, you need to check for the compatibility between the other ones. And then you will have to do the maintenance upgrade the libraries, the client libraries for every component. So it's painful. I'm sure we have developers in the room or people even who used to be developers. And can you please raise again your hands? For the developers. Okay, cool. Now, keep your hands ways, if you can both develop the microservice in, let's say, Java, Go, or Python, but also integrate it with Python. Who can do that? Integrate it with Keycloak, for example, sorry. So the microservice and Keycloak. Okay, now if you add Redis on top of that, so adding caching, authentication using Keycloak, the microservice in itself, then adding secrets management, we have no more hands left. And that's the reality today. The developer doesn't only need to add a business impact to fill a gap in a business application, but he also needs to be skilled in all of the components that the microservice is connecting with. So that's what we come
It's
to.
too complicated, so we need to learn all those tools to consider ourselves microservices developer. So in order to put microservices in my CV, I need to learn Kafka, Keycloak, Redis, MongoDB, and now especially actually if we can consider CNCF landscape tools for our microservices, it's going to be too tough. The thing that's a developer, he's supposed to be a developer. In the old days, actually, when you ask someone, what do you do for a living? His answer is going to be simply, I'm a Java developer. I'm a Python developer. I'm a JavaScript developer. So the thing that developers are based in the central circle, as you can see there. He's well skilled in designing and building good business models and good code for the business. So his work is to focus on the main goal, which is the business part. All the tools, as Jeremy did explain around, are for him just tools that he needs to configure it once, and he don't care about it. So tomorrow, if he needs to update or to upgrade or to fix an issue with Kafka or Keycloak or any tool around, it's not his job. I'm a Java developer. I'm a Python developer. It's not my job. And there it starts, actually, it's not my job theory. It starts to be well common in the community and the market because there are a lot of tools. So for developer, paradise is not this, but this. So for the developer, for him, I need to focus on my code. I need to focus on the good practices, the good design pattern. I need to implement good code quality. I need to focus only, even for security, for vulnerabilities, only on my code, only on my technology that I'm working on. So if I've got a vulnerability in the messaging server, it's not my issue. It's not my job to fix it. So for him, we are looking for a solution. We've been looking actually for a solution, to abstract and to facilitate and to make it easier for the developer to manage his code and to give him a push to focus on the code. So for him, as a developer, he needs to focus on his code and all the tools around needs to be abstracted. The question now, how to unit them all? Is that feasible? Can we do that? I like Linus Torvald, and he said, talk his ship, show me the code. So on the left side, we've got a Java application. It's a basic, actually, main method, send message. And all this code is just to send a message over Kafka. So as you can see here, we've got a lot of properties. We've got a lot of verbosity, a lot of configuration that the developer doesn't care about it. For me, I'm microservice developer. I know that I did this design, this architecture. I know that microservice A should send a message to microservice B. I don't care how it's been sent. On the other side, this is the goal of this presentation. We've got Dapr, distributed application platform, application runtime platform, which has his client. Dapr gives you the possibility to do this abstraction and gives the possibility to the developers to deal only with one tool, who is Dapr, and basically he's the waiter in the restaurant for you. He's the one that is going to do everything for you. Guys, this is just an example. It's not doing just messaging. It can do database stuff. It can send messages over GMS. It can even do push-based communication. It can send requests. It can save stuff to the database. You can even deal with actors in your microservices over Dapr. So Dapr did the abstraction, did give us this possibility to do this abstraction and to make the developer life easier. So, Jeremy, could you please tell us about the history of Dapr?
Dapr, it's an acronym, in fact, for Distributed Application runtime. It's been originally developed by Microsoft, so they have been pushing a lot recently for open source projects. They have been doing Headlam, the dashboard for Kubernetes, but in this case, they pushed for Dapr. They donated it to the Cloud Native Computing Foundation, the CNCF, in 2021, and it's been graduated approximately 1 year ago at the end of 2024. And with Dapr, they contributed to something really valuable in the cloud native environment. They did a standard vendor-neutral layer that can glue applications and components together. So, Dapr, it's introducing one simple idea: stop wiring your microservice and your external component by hand. You will stop connecting directly with your client libraries to Kafka. You will only have one library, so Dapr 1, which is available in nearly every runtime, so Node.js, Python, Go, PHP, Java. You will just include this library in your application, and your library will make only one standard API call to a daemon that will execute the Dapr runtime. When you start the daemon, you will specify as code, so it's basically a Kubernetes-like YAML manifest. You will start Dapr with components. The components, it's the blue squares that you have on the right. You can declare a pub sub component, and the implementation of this abstract pub sub is Azure Service Bus. You could implement a state management abstract component, and the backend behind it is Redis. But your application code doesn't care whether it's Redis, whether it's Azure Service Bus, whether it's AWS SNS SQS. It's the same. And the best part is that if you are currently on-prem but using Dapr, if you just now move to the cloud, you do not need to rewrite all of your code. You will just change the YAML component, and your application, you can deploy it directly on the cloud. And as always, so we have you have multiple clouds provider, we have some components, but it's open source. So the only part that is missing is the one that you haven't added yet to Dapr.
Thank you, Jeremy. So how it works? As Jeremy said, actually, one of the really advantages of Dapr that it gives you the possibility of literally do the lift and shift. So how it works behind the scene? So Dapr is based only on a simple pattern. It's not that simple sometimes, but it's well-known pattern in the Kubernetes world, I think in the container-based world, which is a sidecar. Technically, what's going on? When you deploy your application, and basically, for the technical geeks here, you add the labels that Dapr gonna add it for you if you use the Dapr CLI to deploy the application. Your application gonna be deployed on a deployment, basically, and you Dapr scheduler gonna add you a Dapr sidecar container next to it. This is the only thing that your application needs to deal with it. So now, as you can see, we did limit the surface of attack in terms of security. Add to that, actually, for those who are working on microservices, in microservices in general, we've got two strategies of communication. There is the push-based communication and the pull-based communication. So the push-based, when the client pushes to get the information, like post request, REST, basically, actually. I'm going to do a post request to get my data. I'm going to do get request to get my data. But in the other side, the second strategy is the pull-based, which is basically based on a messaging broker. There is an instance that notifies you, hey, there is a message. You need to pull it, and you're subscribing on the specific topic, and then you pull the messages. As you can see, Dapr make it even easier. There is no pull-based. You just communicate over HTTP or gRPC, actually. It's up to you to choose. And as you can see here, we've got a ready-to-use from the Dapr daemon, from the Dapr D sidecar container. We've got a ready-to-use, actually, method to invoke a method, like to do a push request. I need to push an order. For example, you can get the state, you can publish a message, you can get secrets workflow, and all these methods are already developed and designed to make your microservices ready to use and to guarantee the communication between each others. So basically, actually, using the sidecar pattern, this is the abstraction. This is the layer where we did abstract everything for the microservices. So in the microservice now, you don't have, I'm going to speak with dependencies, for example, you don't have a dependency for Keycloak. You don't have a dependency for Redis. You don't have a dependency for MongoDB, for example. You just need to add the Dapr client. And the Dapr client is supported in the majority of programming languages, actually, which is Java, Python. You can check the documentation on Dapr.io to see all the supported programming languages. And even if it's not supported, actually, you can create. It's basically a REST request. You just need to invoke this method with specific body. You just create it by yourself. A simple curl, actually, command can do the job for you. So as you can see here, this is the abstraction layer. This is where the barrier, where we did actually break the barriers with all the complexities of the different tooling and the tools that we need to master, we need to implement, we need to configure. No more that. Just, I need Dapr, and Dapr is the agent. You can consider it as an agent, as an instance, as a sidecar, basically, technically. You can consider it as a sidecar that is going to do everything for you. So now, if the sidecar is responsible to take my requests, where my requests are going to be in the next step, simply components. All the things, as Jeremy did explain in the second layer, are basically components. This is the abstraction in the operation layer. For me, I don't care if you need Kafka, if you need ActiveMQ, AWS SNS, Azure Messaging Bus. I don't care about that. Give me just the template. I'm going to look in the Dapr.io artifact hub. I'm going to check if it's supported. I'm just going to take the component, implement it, and I'm going to communicate with the component. And the component is going to forward all the things, the messages, the resources, the data for the dedicated tooling. So as you can see here, those components has main role actually to guarantee and to connect applications together and to guarantee the good behaviorals of the microservices together in your architecture. So those are some of the different types of components and the supported one. And always remember, basically, it's working on Kubernetes. So if you've got a component that it does not exist, you just can create a CRD. And I've been actually seeing some talks, very interesting talks in this conference about KRO and even about creating some specific operators and stuff. And I really like how it's easy today to create CRDs and to create specific components in this case. So we're going to dig deeper with some components type. Let's start with the PubSub.
Let's take a concrete example. You're a developer and you have an orders microservices. When you receive an order, you want to push a message on some queues so that it can be pulled later by the component who will handle concretely the order. You're a developer. You don't want to handle all of Redis documentation and adapt your code to Redis. You just want, it's an abstract operation, send the message to a queue. Then you will use the standard Dapr language, if we can say so, by doing a post request or using gRPC to the Dapr sidecar. Then Dapr will have the logic to interpret your message and translate it for Redis. If tomorrow you move from Redis to Kafka to a specific message broker, you will not change your code. The code and the call that you will make to the Dapr sidecar will be the same. It's just a Dapr daemon that will basically change the language it translates your request for Kafka or for Azure Service Bus. And it's the same in the other side. So when you receive a message, you don't have to specifically listen to a Kafka topic and adapt with the consumer producer configuration. No, it's Dapr who will have the logic of correctly listening to your queue and who will push you whenever there is a message that is received. He will push you the message using a basic HTTP endpoint. Same for the secret store. You have cloud native applications, so secrets are not hard-coded. They are stored in a key vault somewhere on a cloud or in Kubernetes secrets. Okay, so if you do not use Dapr, you will create your application by binding it directly, hard code, I would say, the connection to Azure Key Vault. But you want to move to Azure for any reasons, and you want to go to Amazon, or you want to do it locally on Kubernetes secrets, you need to rewrite all of your code, which is a pain in the ass globally. So with Dapr, you could just update the component, so the YAML, and your application will be compatible with the new secret store. The complexity of having different components is abstracted and is taken out of the application to be put in some YAMLs of configurations.
So, enough talking. It's demo time. So you remember the microservices architecture that we did present at the beginning? So it was tightly coupled. Now everything is abstracted. We're going to connect with Dapr. We're going to create some Dapr components. And we're going to see what are the advantages of this architecture life. So now we're going to start simply with a local deployment. So we're going to deploy our application locally on a local server, actually, a Docker Engine server locally. So basically, we're going to use the secret component that Jeremy already presented and the Redis component. So can we start the demo?
Yes. So if we have a look at the code, we basically have a Docker compose YAML files where we defined 3 microservices, the articles microservices, which is a Java code. Then we defined the Dapr sidecar that is running on the same network than the application. With Docker Compose, we can do that by using the network mode attribute so that both reside on the same network.
And the thing, actually, that as you can see, can you please go for the labels? Yeah, this is good. So as you can see here, actually, there are controllers behind the scenes. So in this environment, we need just to have the Dapr daemon. We need to have the Dapr system. And the thing is that it's not only for like Kubernetes or Docker engine or something. Just you need a system that it's going to manage your containers. Even for Podman, actually, single engine mode, you can use it. Just you need to have the system behind, and you need to have the labels in order to trigger the controller and the scheduler to give you the sidecar process. I'm going to call it process from now on, because it's not like only for pod context or Kubernetes context next to you to give you what you need to your microservice. Add to that, actually, this is Docker Compose, as you can see, single engine mode. Even in Kubernetes, we're going to see that in Kubernetes, it's much more easier because we've got the operator, the Dapr operator we did install it. But here, this one is the basic example that we are using only Docker Compose locally on our machine. Can we go to the UI, please, Jeremy?
Yes, so it's there.
OK, so we are not front-end developers at all. Sorry for the colors. Sorry for the UI. We did develop this like in one day. And OK, as you can see, this is our e-commerce application. As you can see, the green color here refers to Docker Compose. So this is locally. We are going to add an order. Can you please add an order, please,
And then let's
Jeremy?
go for as extrudes.
You like that.
So
you like
ID,
no balance.
ID4.
Yeah, OK.
And if we have a look, this order just came up. This is basically, if you cannot translate timestamp to date, it's the timestamp of right now. And the article ID is indeed article 4, which is ASICS shoes.
OK, this is just the demo, guys. So it's not like no production-ready application or something. OK, can we now pay the order?
So when we pay the order, we are calling, in fact, 2 microservices, one that is preparing the payment and the other one that is processing the payment. For dummy and mocking reasons, we put a slight delay when you click on pay. So there is like 5 seconds.
We did click
and
now.
It should say pay. OK.
And the thing that the workflow now, as you do remember, we've got 3 microservices. The 3 microservices now actually did communicate, as you can see, over Redis and secret. And simply, they do not know Redis and they do not know the secrets locally. They did ask Dapr, hey, I need this secret in order to start. I need to cache this state or to cache this info in my cache in Redis. I need to cache it. That's it. You should not mention any tooling. And the workflow works fine. So next part is the most funniest part. So we are going to AWS. But there is something really important that we are using the exact same images. The exact same images configured with Dapr client. The only thing that we are going to change, that we are going to deploy the microservices with the exact same images on top of EKS, Elastic Kubernetes Service on AWS, using Dapr also. And we did create two components, Dapr components. One is the Dapr component for SNS SQS for messaging, and the other one is for Amazon Secret Manager. So can we go for the demo?
Yes, so let's check the components that we were talking earlier. I said there were like Kubernetes manifest files. If we have a look at the secret store components, basically it's so you have an API version that corresponds to Dapr.io. It's a kind component, and you give it a name, of course, and type. Here is what it gets really interesting. It's a secret store, and it's particularly on AWS secret stores. You access it through access key and secret keys, of course, but that's the definition of a component.
The thing that, because we got this question before when we did present it in other conferences, that it has its own provisioner. So Dapr himself gonna start or create the SNS SQS topic for you directly. You don't need to go through Terraform or Crossplane or AWS CloudFormation or something. Dapr do anything for you. That's why we need to give the component actually access to the AWS environment. Can we go just for the SNS SQS component? Here, actually, the subscription, please. Thank you. Here, actually, in the subscription, we did actually mention that the orders needs to be subscribed to the PubSub, because there we are going to send the article from the article microservice to the order. So could you please link this microservice to this endpoint? I don't know which tool behind SNS SQS, Azure PubSub, or whatever. I don't know about that. So it's completely abstracted. Can we go to the UI, please?
Yes, let's just enable the port forwarding. So we did not develop all of the ingresses. We just did a port forward on the kube cluster so that it's faster. And we need to update the UI.
Just the port. The other one.
Done.
It's already done?
Yeah.
Okay. Okay, the official color of AWS just shows up. So here we've got AWS-based microservice architecture deployed. So as you can see now, everything is in orange. So everything is deployed on AWS fully. Can we go for the New Balance one? I really want that one.
Okay.
We are going for the order.
It's this one. So we see article ID is 5, which corresponds to New Balance 1. And as previously, if I click on pay order, there is this slight delay to mock a real payment. And then we will have the paid success message.
So everything is working fine. Reminder, very important to mention, it's the exact same code base. And I don't know if it's been changed already. So tomorrow, if I'm a developer and they did change from AWS to Azure, for me, it's fully abstract. I don't know everything about that. Now, we did locally, we did on AWS. It's time to go to Azure. Microsoft, don't worry, we will not have the blue screen here. So here, we've got Azure Key Vault instead of AWS Secret Manager. We've got Azure Service Bus, and we are going to deploy the application on AKS.
So here, same thing. We did deploy our base images, the deployment on the Kubernetes cluster in Azure, but then the secret store, previously it was a secret, the type of the component was secret store.aws. Here we can see that it's secret store.azure. So the type is a key vault in Azure. And I just precise the vault name in Azure. So we have deployed that. I will enable the port forward on the cluster. And I will just update the front end.
11111. Someone call 111.
And if we go to the UI, we now see that it's blue.
That's blue, don't worry.
Yeah. Okay. So if we do an order, let's take the Puma one, and we click on order, it should show up here. Indeed, we have the article ID 1. If I click pay, as previously, it will have the slight delay, and it will show pay.
Thank you. Yeah, go for
As
it,
Hajed said, the real important thing is that we didn't change the code. The code is the same. The only part that changed is this YAML declaration, the component that doesn't refer to a AWS one, but to a Azure one. Okay?
Thank you, Jeremy. I can see you're excited also, but I'm excited for something very, very important. Imagine now that we are going to sell this e-commerce application to some companies that it's a must for them to deploy the payment process in their region. And they want to use AWS for payment, but they are OK with Azure. Then, at this moment, it's the time to juggle. We can't go for a multi-cloud environment. And guess what? It's the exact same code base. So as you can see here, we are going to keep all the article microservice in Azure. We are going to migrate the order management, which is linked tightly to the payment process, to the payment microservices on AWS. And we did choose to keep the messaging server and the AWS Secret Manager on AWS also, but all the article management microservice is on Azure. Is that feasible? The answer is yes. And again, it's the exact same code base. The developer is not aware about what's happening behind the infrastructure and behind the scene. So can we go for the demo?
Basically, what we will be changing is this tunnel here. So Dapr will not send anymore to Azure, but to AWS. And this, we already choose to variabilize it and to store it in the key store in Azure. So we have the pub subname key. I will change it. It was previously the pub sub that was configured to go to Azure, and I will change it to the pub sub that will go to AWS. So for that, I just take the name of it. I put the value. I do create. OK, current version is good. And I will restart the pods so that the changes are taken into effect.
Actually, the first thing that we did execute this, I thought that's going to explode. Like, no, we don't work with AWS and Azure together, but it works. OK. So, as you can see here, very good about the port.
Should be.
OK. As you can see here, we are in the Blue website, so we are on Azure. This is the article management, so you can browse articles, and then if you add an order, and we go to the orders, there is nothing. It's not working. Good. So just need to check some stuff.
Let's imagine that we have it.
It's been working 5 minutes before the talk, actually, so it happens.
As always.
Just the port of the orders. No. Put it. Well, good. Okay. It's working now. So here, sorry guys, but this is just a demo application. So here we've got the order. It comes to AWS. Now it's orange. In the Azure side, in the article management, it's blue. It's on Azure. On the order management side and the payment side, if we do pay order, we wait for a couple of seconds. It's going to be turned paid. The payment is on AWS. So technically now what we did, actually, we did provide a solution. Like, it's not us, it's Microsoft. Thanks for Microsoft. At least they did something useful. So at least now we've got a solution to do an abstraction for the developer and to be literally cloud agnostic. So this is the thing. This is how we did manage to build literally a simplified and portable cloud native architecture.
And so for teams moving away from monoliths, or if you are migrating your application to cloud or between cloud, or even if you are starting a new application, Dapr is really the solution because it's bringing faster development time because you don't have to worry about connecting especially to Kafka handles, Kafka TLS logic, and so on. But you have also easier maintenance cost. You don't have to upgrade your libraries every time, upgrade the components. You don't handle that part. You have a true portability between cloud environments. You can do it on Azure, and then for prod, you put it on AWS. And most importantly, you are bringing back time for the developers to focus on the real added values of the applications and not handling infrastructures issues.
Thank you.
Vielen Dank.
Big round of applause. How does Dapr avoid introducing additional complexity regarding permission management? Do I start one sidecar per microservice?
Yes, so you will have to start one sidecar per pod, because basically each pod will connect to each sidecar, and it's the sidecar who will make the request. Now, it doesn't change anything for the role management as it was before. It's just the API calls that are being made by Dapr and no longer by your application.
Next one is, can Dapr handle key rotation for a database, for example? Would it need to restart if the key to the DB changes, or does it have the functionality to update live?
Yes, I would say technically yes. With this abstraction, actually, you can manage all the, you can even automate those type of functionalities of key rotation for databases, or updating like licenses or certification for some components. This is the utility of the abstraction that, okay, now I'm not gonna manage a specific tool, I'm gonna give it to Dapr, and I'm going to manage the Dapr component. So this abstraction is very similar to the abstraction of a container or of a pod. Now I manage only a pod in Kubernetes. In the context of microservices, now you're managing only components. So when you're dealing with those things like the key rotation, certificate update, management, or anything, you are dealing only with a component, which is an abstract thing. So it facilitates the things for you.
One last one. Adding Dapr also add extra layer of latencies, and it's adding sidecars, so adding one more hop. How can this be moved away from to SDK based rather than sidecar?
It's adding time in the request, of course, because you are adding indeed a new hop. So it will take resources in your cluster, and it will take a slight time for the request to be translated from the application in Dapr to the external component. But honestly, it's really mini increase, but yes, it has to be taken into consideration. Of course, there are drawbacks in every solution.
I would add just one thing, that latency in some specific cases, specifically for this solution, it's worth it actually to sacrifice some latency in order to have this thing for automation and for especially actually for abstraction for developers.
It's the same with Istio, in fact. You are adding Istio sidecar mesh, you will be adding latency.
Well, just one last thing to consider it, like it's not perfectly correct, but consider it like Istio for layer 7 for applications. Consider it like that. It's not like 100% correct, but it's the thing. Thank you.
Another big round of applause for our speakers. Thank you so much.
Thank you so much.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.